So hello everyone, welcome back to the crash course series. Let's start with the next chapter of our crash course series of chemistry, which is amines. So let's give the heading here, amines. Amines. Okay. So what are amines? In your book you will find it as it is the chapter name is nitrogenous compounds and amines. Okay. So what are amines? Amines are right here. Amines are organic compounds made of ammonia. Okay, so what is ammonia? Ammonia is NH3. So any organic compound which is made up of ammonia is called amines. Okay, so let's now classify amines in various categories. So when you want to classify amines, if you have to do this, just a minute. Okay, so if you have to classify amines, we have 1 degree amine, we have 2 degree amines, and we have 3 degree amines. So let's give the heading. So types. Okay, so under the types we have 1 degree amine, you can also call it as primary amine. Second, we have 2 degree amines. Okay, and at last in third we have 3 degree amines. Right. So what is the structure of our 1 degree amine? It is RNH2. See, one hydrogen here is being replaced by your R. R is any alkyl group. Okay, so in 2 degree amine what happens? R in R. You have to remember that nitrogen has lone pair, and for 3 degree amine, R in R, and here also an R. Okay, so this is the structure of your 3 degree amines. Okay, so here you can see as soon as the R is increasing, one of the hydrogen is being pulled out of the in nitrogen. Okay, so there cannot be any 4 degree amines because of the non-availability of your hydrogen. Okay, so copy it up to this much. Next we will discuss about the various physical properties of amines. Okay, so copy it. Done. So before doing the physical properties, let's first see about the physical occurrence or the physical or the practical use of amine in our daily life. Okay, so what is the practical use of amine in our daily life? So you can write here like this number. Okay, amines are used for the synthesis. Synthesis means amines are used to make your various drugs and dyes. Dye means colored organic compound, okay, which imparts color. Everything, the clothes we wear are made up of, the colored clothes which we wear are made up of dye. Okay, so under the drug category you have to remember that Novocaine, it is a anesthetic drug, anesthetic drug made from amine. What is the use of this drug? It is used in dental purpose. Okay, next thing is the biological occurrence of amine in our body present in form of hormones, protein and vitamins. Clear? So this was about the physical occurrence of amines. So you copy it up to this much. Next we will start with the preparation of amines. Done. So let's start with the preparation method. The first preparation method which comes to our mind is the thing which we learnt in the alkyl halide chapter. If you followed the series, it was the Hoffman ammonolysis. Okay, so let's remove this portion. So give the heading methods of preparation of amine. Okay, so there are various methods of preparation of amine. We are getting the first one, which is the ammonolysis of alkyl halide. Okay, so you give the heading under methods of preparation MOP, which is ammonolysis of alkyl halide. So what happens here, if you remember, we did this in the haloalkane chapter in the chemical properties. We take RNH2, which is a primary amine, with Rx. Rx can be any alkyl halide. Okay, so what happens here is, see, from here this X will be removed and one hydrogen will come out. Okay, so you get minus 1 HX and this R will get added here. So you get R. So you get, okay, sorry, I am doing this a bit wrong. You have to begin with primary amine first of all. Okay, so that was a mere mistake which was done by me. Let's begin with the primary amine. Okay, so let's take Rx plus NH3. Clear? This is ammonia and this is a alkyl halide. Okay, so what happens here is, this is delta negative and this is delta positive. Clear? So what happens here is, and here you know it is there is lone pair. So what happens, the lone pair is negatively charged, so it will have a tendency to attract the or to go with the plus charge. Okay, so this N will come over here. Okay, and this X will be removed otherwise, and this one hydrogen from here will come and get bonded with this. So what happens here is, we get R N, I'm sorry, let's increase this, we get R NH2 and minus HX, right? One hydrogen is getting this X and it is coming out at HX. So this is primary amine. Okay, now primary amine, from primary amine we will again react it with some Rx. Okay, now this was the thing which I was showing earlier, which I did the mistake. Okay, so you have to check it, keep that in mind. Okay, so what happens here is the same thing will happen. So this here is a delta negative and here is a delta positive, so the R will get attacked and here. So what happens is R N R and one H and you get another HX. Okay, now when you again perform the same thing, you get 3 tertiary halide, alkyl halide, tertiary amine, I'm sorry, which is R N R and here also one R. Okay, and here also one HX. Now from here, if you again perform the ammonolysis with Rx, okay, what happens here is, since there is no hydrogen, the R will be added to this lone pair. Okay, so what happens here is this type, Rn R R and R. Now since the nitrogen is losing the electron or donating the electron to accept the alkyl halide, so here an entire plus charge will be created over here, right? And since this time there is no hydrogen in the 3-degree amine, this is 3-degree amine, and since there is no hydrogen in the 3-degree amine, what happens, the halogen will get bonded with this and form a salt like structure. This is called the quaternary ammonium salt. So if you want me to write there, I have to accommodate, so let's remove this for the time being. So quaternary ammonium salt. Clear? So this thing, quaternary ammonium salt, is this one. Clear? So and this entire thing is called Hoffman Hoffman ammonolysis. So I am having problem in accommodation, so let's make this a bit small. So Hoffman ammonolysis. Clear? Okay. So what happens here is we take ammonia and we react it with alkyl halide. So we know ammonia has a lone pair and alkyl halide R and X. This R is delta positive and X is delta negative. So what happens? Delta positive will get attracted towards the lone pair of the ammonia, right? So what happens? The RNH2 is formed and one hydrogen is coming out from ammonia to form the HX. Now similarly, on repeated alkylations we see 2 degree 2 degree amine is formed, and then 3 degree, and at the end quaternary ammonium salt is formed. Now if they ask you why the quaternary ammonium salt is being formed, then you can easily answer that since there is no hydrogen in the 3 degree amine, so the entire thing being a positive charge and X being a negative charge togetherly forms a complex salt which is called the quaternary ammonium salt. So copy it up to this much. Next we will learn about the further processes of preparation of amines. Copied? Okay. Next we will learn about the preparation from the reduction of the nitriles. So this is going to be number 2. Just a minute. So I am erasing this. All right. So let's make it once again this line. Okay. So the next method which we are going to learn about the preparation is from the reduction of nitrile. We know nitrile is RC triple bonded N. So give the heading next method of preparation, which is reduction of nitrile. Clear? So what is a nitrile? Nitrile is RC triple bonded N. So RC triple bonded N. Now reduction can be done in 2 ways. If you want to do it directly, then you have to perform full reduction, and if you want to do it stepwise, you have to perform the Stefan's reaction. Okay. So let's see what is happening here. Let's first discuss about the direct reduction. Okay, so what happens in direct reduction is you take platinum, palladium, nickel. Okay, platinum, palladium, nickel, nickel, hydrogen catalyst. Okay, now what happens here is simply we will get an amine. So what happens is RCNH2, it will become RCH2 in H2. Let's remove this. This is coming of no use. Okay, so it is coming RCH2 in H2. So this is the, you can say, full reduction product. So you can write it here, full reduction. Okay. Now if you want to perform it stepwise, then the thing which we do is called the Stefan's reaction, which we already studied in the aldehyde ketone chapter. Okay, so what happens here is, if you take the Stefan's reagent, which is the SnCl2 plus HCl, what will happen here is aldehyde will be formed. I am sorry, not aldehyde, imine will be formed. Okay, so RCH. Okay, imine, you have to remember the structure, which is RCH double bonded NH. Now this is called amines. Let's write it with different color. This is called amines. Okay, and this is called Stephen's reagent. Okay, now this is called amines. Now amines, when you again perform SnCl2 plus HCl or the Stephen's reagent, when you treat it again with SnCl2 plus HCl, then it will again be reduced, and as a result the thing will be formed is a primary amine. Okay, now this is amine. Now if you remember the aldehyde ketone chapter on the hydrolysis, on performing the hydrolysis of amine with H3O plus, we get the aldehyde. So if you want to associate the chapters, so if you want you can write it here, otherwise it is not necessary. Okay, so let's write here. If you perform hydrolysis with H3O plus, the thing which is formed is called the aldehyde, RCH. Done. So this was the end of the reduction with nitrile portion. So copy it up to this much. Next we will learn about the reduction of the amide. So copy it. Just wait a while, I will refill my blue ink. It's finished. Now in the reduction of amide, so what is amide after all? You have to know about it. So amide is RCOONH2. So what happens in the reduction of amide? I am going to show you just now. Okay, so my ink is refilled. So let's come back to our work. Just a minute. So we are going to discuss the reduction of amide. So if I ask you to name a strong reducing agent, so what is a strong reducing agent? This one is a strong reducing agent, but apart from this we have lithium aluminum hydride, okay, which is LiAlH4. So reduction of this one will be amide. Reduction of amide. AMID. Okay, so what happens in the reduction of amide we are going to see now. So what is amide? I have mentioned it is RCOONH2. Now here you have to take the reducing agent, which is LiAlH4. This is lithium aluminum hydride. So as a result you get your 1 degree amine, RCH2NH2, which is primary amine. Clear? So this was the reduction of amide. So this is LiAlH4 and you have to take water H2 and instead of that thing. Okay, so this was the reduction of amide. So let's move on with the method of preparation. The next thing which we have is from the reduction of nitro compound. Now what do you mean by nitro compound? It means it will have a NO2 group. So what happens? Let us take reduction. So let's give heading reduction of nitro compound. Okay, so what happens in the reduction of nitro compounds? Let us see now. We take a nitro group compound, such as, let me take the nitrobenzene. Okay, clear? This is the nitro compound. Now if you want to perform reduction, you can take the C2, let's do it with another color. You can take the ethyl alcohol, okay, C2H5OH, or you can take Fe plus HCl, okay, or you can take the Sn plus HCl, now any of this. But the book says that Fe plus HCl is the best method, which gives the best product. Okay, so what happens here is you will get a amine, and this thing is called aniline, which is going to come in the diazotization portion, which we will discuss after the amines. Okay, this is called aniline. Okay, aniline. Clear? Now, if this was the about the benzene, now if you want to do it with CH3NO2, it is also possible. CH3NO2. Now, since this is the best, I can take it the best method, obviously, which is Fe plus HCl. If you take there, you will get CH3NH2. Clear? So, copy it. After this, we will do with the two name reaction, which is the Gabriel P Thalamide synthesis and the Hoffman bromonamide synthesis. So, let's copy it. Done? Clear? So, let us continue with the Gabriel P Thalamide synthesis. So, let us take the board. Okay. Now, this is a very important reaction, and it is a name reaction also. So, you have to keep it in your name reaction list. Okay, so let us begin with the Gabriel P Thalamide synthesis. So, let us begin. Give the heading Gabriel Thalamide synthesis. Now, this thing is very important for your exams. Okay, so let's put, this is thalamide, I'm sorry, thalamide. This is Gabriel Thalamide synthesis of ammonia, of amine, I'm sorry. So, this is very important. So, let's make a star. Okay, this is organic star. So, let's write what happens here is, so if you have seen the thalamide, thalic acid, I am sorry, it looks like this. Okay, so it is COOH. Now, if you break this, it is also looking like C double bond O single bond OH, and here also the same thing, C double bond O single bond OH. Clear? This is the thalamide. If you want to write the name, so let us write the name. This is called thalamide. Clear? Now, thalamide, when you treat it with three things, okay. So, what are the three things? You have to take a base. First, you have to take a base, which is NaOH, or you can take KOH. Next, you have to take an alkyl halide, which is RX, and the third category, you have to take water. Okay, so let's write here. Now, from this, the result which you are going to get, I am taking NaOH. Let me assume for this reaction. So, what happens is, we are going to get this thing. This one C double bond O, this one C double bond O, and this entire thing will join here with the Na. I am sorry, I did a mistake, and this entire thing will join with Na. But we are not concerned about this, because this is not an amide. We get amide from this RX. Okay, so you get RNH. Clear? Okay. Now you have to write a few important points about this reaction. Okay, so let's give the heading important points. So, important points. So, what are the important points here? So, you have to write primary amine exclusive. right? Next is take alkyl halide only. I hope my ink is visible. Yes, it's visible. So give the heading take alkyl halide only. And the next point which comes is why we will take only alkyl halide, as because as aryl halides cannot give SN reaction, do not give substitution nucleophilic reaction. Okay, so this was about the Gabriel P thalamide synthesis. So what did we do? We took the thalamide, which is the structure like this, the benzene ring is there and two C double H is spreading out. So after that we react it with three reagents, which is NaOH or KOH. We take one alkyl halide, remember it is alkyl halide, not aryl halide. Okay, we take NaOH, one alkyl halide, and we take water. Simple, done. Then you prepare, then you just open up this OH, you put Na over here. Okay, and you take this R and you put NH2. Okay, so right of 1 degree amine. Clear? So copy up to this much. After that we will continue. Clear? Okay. The next thing which we are going to learn is the HBD reaction, which is a very famous reaction after all. Now this is a descent of chain reaction, you have to remember that. Okay, so what is HBD? We are going to discuss now. Just a minute. HBD means Hoffman bromonamide degradation reaction. Okay, so give the heading. Let's clear it out. Okay, so HBD means Hoffman bromonide degradation. Okay, I hope I misspelled the spelling. No, it's correct. Hoffman bromonide degradation. So what happens here is, let's write the reaction first, afterwards I will explain. Okay, so what happens here is, since see bromonide, that means amide group is present. Okay, so let's take amide group R C double O N H2. Okay, so this is the amide group. Now amide group, we are taking bromine over here. Since bromonamide, so we are taking bromine. But remember that bromine which you are taking has to be only 1 unit of bromine. This is a very important thing. So RNH2, Br2, and then you are taking a base, which is NaOH. And as a result of this, the thing you are getting here is again RNH2, RNH2, which is the primary amine. Okay, done. Now if you want to write the outcomes of this product or the byproduct of this reaction, then you can write Na2CO3, NaBr, and obviously H2O is coming out. H2O. This is called the Hoffman bromonamide degradation. Now, why it is called degradation, I am going to explain now. So, let us see why it is called degradation. Now, if you see, this is RCOONH2 and this is only RNH2. Okay. So, can you notice the difference here? One C double bond O is there, and here there is no C, and this C is over here. That means there is a descent of chain, we call it, because this is an alkyl chain, right? And one CO2 is being eliminated. So, this is the CO2 which is coming out as Na2CO3. So, this is called the descent of chain reaction. Okay. So, let us write here descent of chain. Okay. So, from here descent of chain, it is getting RH2. Clear? So, this was all about the Hoffman bromonamide degradation, but the important thing you have to note it down over here is you are taking only 1 unit of this Br2. Clear? So, copy it up to this much. This was about the preparation. Now, we will move to the physical properties. Done? Okay. So, keeping this video up to this much. Next video we will learn about the physical properties, chemical properties, and after that in the next video, means the second video and the third video, we are going to learn about the diazotization process. We are going to complete entire diazotization. So, copy it up to this much. Keep watching. Thank you for liking this video. So, copy it. In the next video we will be meeting soon. Okay. So, bye.